Alright, so this is 9:47, and it says at 10 a.m. a radioactive material weighed 2 grams, but at 6 p.m. it only weighed 0.45 grams. What were the approximate hourly multiplier and the hourly percent of decrease? Okay, so what they did is they gave us how much we started with and what time we started with, and then what did we end with, and then the time that it ended. So we know that this is an exponential function, and A is the amount we start with, B is the multiplier, and T is the time. So with this particular problem, our initial value is starting with 2 grams, and we ended with 0.45, and then the time that expired from 10 a.m. to 6 p.m. is 8 hours. So this is B to the 8th. Now, this problem is kind of out of sequence because we haven't talked about fractional exponents. So I suspect many of you probably couldn't do this problem. You probably could set it up, but what we want to do is solve for B, and so we have to isolate it. So you divide by 2 and you divide by 2, and so then you get 0.225 equals B to the 8th. Okay, now when this is B squared, we take the square root of it, but the easiest way is going to be to raise this to the 1/8 power. So when you raise this to the 1/8 power, the 8 cancels, and so we get B. But realize in algebra, if I do this to one side, I got to do it to the other side. So then we're going to raise this to the 1/8 power. And so when you do this, you take 0.225 to the 1/8 power. This ends up being 0.83. And so our multiplier is 0.83, and that's our answer. Now, like I said, I suspect many of you probably couldn't do this problem because we haven't talked about fractional exponents yet. So don't panic. It's not going to be on a test or anything just yet.